Hi everyone, my name is Chris. I've been in Hong Kong for like 3 years now, doing basically web development for iPad apps. I've recently become interested in a new technology that's about creating something called Dapps. And I'll let you know what a Dapp is later on, but first I want you to put up your hands, everyone. I want to start off by doing like a negative poll, so if everyone can put their hands up to start off with. And you can put your hand down if you've never heard of Bitcoin. All right, never heard of blockchain? Okay, never heard of smart contracts? Cool, Web 3.0? All right, and Ethereum?
Well, I have to put my hand back up?
Yeah, you can put it back up. Cool,
My
so we
knowledge is
have
very thin.
a few Ethereum. Cool, so about good range. I'm going to basically introduce the whole topic to you and try and explain why it's cool, why it's new, why it's interesting. But to start off, I need to kind of explain a macro kind of context for this talk. So basically the web is evolving constantly, and we all have kind of heard of Web 2.0. It's about doing things slightly differently in the browser, but I think we're on a new plateau of Web 3.0, and the kind of background of 3.0 is all about distribution. So in the typical client-server model of Web 2.0, you can see this decentralized middle kind of architecture where you have almost a monolithic server that deals with requests and responses. That's okay, it's worked for us so far, but there's a better way of doing it, and that's called distributed networks. So that covers BitTorrent, WebRTC, blockchain, and some various other technologies that I'm about to talk about. So if we think about the web as shifting to this new paradigm, this technology is basically the keystone of allowing that shift to happen. Why is distributed better? In the words of Daft Punk, it's harder, it's better, it's faster, and it's stronger. It's harder because censoring is difficult.
You should make a song about that.
I should have, yeah, I need a sound clip. If you want to censor someone in a distributed network, you need to censor everyone, basically. Because there's no central server, you can't just shut it down. Better, because other reasons. I just wanted to fit in with the Daft Punk program. Faster, because it's low latency and there's a higher bandwidth. If you have a distributed model and you want to download a file, I mean, in the old version, you would have to go to the States and deal with that 100 millisecond latency, deal with the download bandwidth of whatever your network is in the backbone. But with the distributed model, if you're next to me, we can deal with the local Wi-Fi network, which is way faster. And there's much less latency. It's also stronger because there's no single points of failure. You can't just shut down a server in a distributed model because everyone else is having a copy of that data and you need to shut everyone down. So buzzwords. I picked a guy in a suit trying to surf because this is how I imagine businessmen trying to explain blockchain technology. It's a little bit more nuanced than just putting it in a sentence and adding value to that sentence. It actually has meaning, and as technologists, I hope you guys are willing to maybe learn a little bit about what this thing is. I refer to it as a magical sky computer. That's basically, for non-technologists, the most you need to say. Because if you try and explain it more, maybe they get a bit confused, or it's getting more complicated than it needs to be. In the same way that they don't need to know about how HTTP works, you don't need to explain how the blockchain works necessarily, you just need to assume that it works. The Economist described it a little, maybe succinctly, as a trust machine. You can see here that they have an analogy of it turning the world around, and maybe this technology is going to do the same kind of thing, but unfortunately they stuck a Bitcoin in the middle of it, and I want to make you guys aware that Bitcoin is not the same thing as blockchain. They're two very related but not the same thing technologies.
I want to make one point.
Yes.
The articles that Chris is referring to there is awesome. Yeah. So if you want to sort of further read, I mean, of course, Chris is going to explain plenty now, but I was really blown away by that.
If you want a kind of non-technical primer on this, it's a great article to read. There are maybe some things that they didn't get exactly right, but it's a great introduction to the topic.
Especially to help perhaps explain some of these things, as you were saying, like not in that businessman on the surfboard way, right?
Right.
Parse it enough to be able to explain it in a non-techy way in the future beyond this.
For the more technical, one way of describing it is a peer-to-peer database as a service that cannot be turned off and cannot be censored. In that sense, it's kind of like BitTorrent, right? You can't just close down BitTorrent because it's not one central place. It's a bunch of things spread out over a bunch of different computers. In the same way, it's not really a thing, but it's a protocol. Kind of like HTTP. You can't shut down HTTP. It just exists, and it's used by people to interact with each other. It's a protocol. The protocol, specifically with blockchain, allows people to come to a consensus about a particular state of a network. It's about, in an algorithmic way, deciding what is true about the state of a particular machine. In this case, the machine is a blockchain, and the blockchain is also a database. It uses cryptography and economic incentives to prevent bad data being written to the database, even if there are bad actors with lots of resources to spend on it. So it's a protocol that's designed to be resilient. And it does that through mining. Mining is a process where basically you have a bunch of people trying to solve a hard problem, and the first person that solves it correctly can prove that he did so, and thereby the network believes him. Because it's really difficult to fake the idea that you're doing hard problems, because you literally need to do those problems in order to prove that you've done them. So basically the Bitcoin network, for example, has hundreds of these mining workshops scattered around the world, created by individuals who want to make money. And they make money by solving this problem really quickly, and they do it really quickly by buying a bunch of graphics cards or special computers that allow you to mine the particular algorithm in a better way. Why is the blockchain cool? The main thing is that it's immutable. So if you write to a database, in a traditional setting, it could be the case that someone comes in and deletes that data and then you never know about it. With a blockchain, everything that gets written is, by design, part of the whole network as it goes on. One way of thinking of it is like a big jigsaw puzzle, wherein every 20 minutes you have to figure out what is the next set of jigsaw pieces that need to go in the row, and that's called a block. And everyone on the planet is trying to find out which pieces go where for that particular block, and the first person that finds out gets a prize. And then the next block happens, but the key point is that when you figure out the first row, the shape of the next row is determined by the answer to that first row. So if you have a jigsaw piece puzzle that's a little bit further down the line, essentially every piece relies on that piece existing. So you can't fake it, and it's there forever. Availability, it's always on. Basically, as long as there's one person on the network that's not you, you can get them to mine for you. You can split up the network, but there are processes involved that essentially figure out problems if there is a split built into the protocol. It's possible to execute logic with this protocol. So essentially, instead of just putting random jigsaw pieces into the puzzle, you can predetermine what kind of logic allows you to put a piece where. And for example, with Bitcoin, you can decide that that logic is a transfer system. So you can transfer coins to one person or the other via a transaction. Basically, each block in that situation would be taking in pieces that people submit based on whether they have the right to submit it based on their balance on that blockchain. So you build into the protocol the logic for handling people transferring that information over. And it's immutable, so the result is Bitcoin. That was the first implementation.
Does it mean that the whole history of the transactions for Bitcoin is included in the
Yes. So if you run a full Bitcoin node, every transaction that's ever happened is on your computer in a big file.
About 50 gig.
Yeah, right now. There are a bunch of different solutions to that, but I don't want to get too in depth with the protocol stuff. But basically the result of it is that security is incredible, right? You're now running a single threaded machine that's based on consensus instead of like PayPal deciding whether or not that bit exists on your hard drive. It's kind of like distributing the logic for enabling transactions to happen in a way that you can trust. And that's the key thing. It's about creating trust, which is why The Economist calls it a trust machine. So if you think about it like a machine that anyone can access in the ether, that you can just send transactions to if you're allowed, and you can guarantee that those things will happen. So now we can enter smart contract land. Given that we can write logic on the blockchain and can execute it, we can now write things called smart contracts. Bitcoin's kind of an example of a smart contract, but essentially it's arbitrary code that can execute in a decentralized way and doesn't require any central party to run that code. It runs across the entire network and is therefore guaranteed to run in a reliable way. And in that sense, you can kind of imagine that now we have code that is true, and it doesn't really matter if you make a law against it because everyone agrees that it's true. It's just what is. It's kind of basic logic, A is A. And you can also send money to these contracts. They can possess stuff and they can send it to each other. So now you kind of have these entities that are not owned by anyone but exist in the world and can interact with each other. They're kind of like agencies. So now we have digital property rights. So smart contracts with this idea basically gives programs superpowers to do things that were never able to be done before. Bitcoin is the first example. Like having a contract, being able to represent something that you can't steal from and you can only trade when you tell it to, is pretty important in terms of programming. Like in a traditional PayPal system, there is no absolute truth there. It's basically what PayPal says is correct. Whereas with this system, it's what everyone else believes is correct. And if you want to send coins to one person, none can stop you, and whatever you send to that as a transaction is going to happen because that's the code. It's not like it can't, it just is. From that basic concept, you can start to build more complex things. So Bitcoin might just be a simple wallet that stores information and sends it when you tell it to, but you could also build something like a multi-signature wallet wherein you have multiple people telling that contract to send money, and if multiple people don't tell it to, it won't do it. Or you could have something like maybe 30% of the people of this contract need to agree in order to send the funds out. Basically, you can create very complex, arbitrary logic for determining whether you want to make a transaction on the blockchain with a group of people. Like we could all deploy a contract today and say, if 50% of us agree that everyone sends the money to this guy, then we do it. But that's on the blockchain, and if we disagree, it's just the code that decides. It's a new jurisdiction of code. Another cool example is a Deadman Switch. So imagine a contract where you put a bunch of money in, and unless you ping it every month, that money is going to be sent to an address that you pre-approved. This is basically a will system. So if you want to inherit your money to your kid, for example, but you want to have access to your wallet, you could build in a Deadman Switch mechanism to the wallet so that if you never ping it in a year, then that automatically gets sent to your next of kin. Now you don't need any legal system for figuring out whether your money should go to this person or that person because it's just in the blockchain and code is law. Another cool idea is a sealed bid auction. So again on the blockchain, right now it's hard to do an auction without there being a central party that might fudge the numbers, especially if there's a really big prize. So if I'm an auctioneer and I know that people are sending me bids, I can actually check those bids and tell the person that I want to win what the best thing to bid is. But you can do it cryptographically by signing basically a transaction that doesn't reveal the result, but proves that you made that choice. And then after a certain amount of time, you have another window where everyone reveals their result, and thereby you get a completely fair auction system that cannot be tampered by a central party. Another cool concept is smart bonds. So if you want to lend money to someone, UBS in particular have built this smart bond system.
This is a very, very much simplified model. In between you have a whole bunch of intermediaries of trusted third parties. You have
So I'm not going to actually show you the model. You can see the architecture vaguely, but they've got a proof of concept. They've created smart bonds, and again, it's another thing that can't be done. And as he was talking about, it's all about disintermediation. That's the key word. It's about removing the middleman. And if you want to start a fintech startup, that's the next hashtag to use. Another cool thing is getting a bit more advanced now, decentralized autonomous organizations. So given that you can put stuff on the blockchain, why don't we try and build organizational structure on the blockchain? Well, it's totally possible. For example, a startup, a Kickstarter, it would usually consist of a fund where people donate money to, and hopefully they get a product at the end. Well, with the blockchain, you can make it so when you donate money, you get direct equity rights of that company, and you can trade them with other people, you can get a dividend on them, and basically you get a much more secure investment than just trying to donate to someone on Kickstarter. And you don't have to rely on Kickstarter existing. You can take that idea and then bolt on some extra contracts, like a salary contract, a board of directors contract. And you can have people make votes on the blockchain based on where the money's going, who you employ, what products you buy, and who you fire. And the salary is paid through the blockchain. You could have a hedge fund element to it, where you employ one guy to invest a bunch of money, and based on various metrics that you guys write in code, he gets hired or fired based on that. And you get a reward from it. Charity is another great example, because if you look at companies in America, some of the charities, like 98% of the money goes to admin fees, which is kind of crazy. 98? Cancer Fund of America.
It's like criminal, right? That's like
well, you'd think so, but well, we can solve the problem now. Basically, by instead of giving the money to an organization, you give it to a smart contract that is managed by someone that basically decides who the end recipients are, as opposed to like who the admin people are. So when you make a donation, you can actually transparently see directly your cash going into the pockets of those who need it. And that's never been possible before. And finally, apply the same thing to government, and you get a completely transparent, non-corruptible organizational structure that is basically better in every way, because there is zero admin cost to it and you can't corrupt it. And the kicker, it's extremely low cost. Like, transactions cost like a fraction of a cent. And compare that to paying someone to do it for you, it's kind of ridiculous. So you've got to imagine all of these things in the economy today that are not optimized in this way. Put a figure on it, let's say it's 10%, and take all of that money and put it back into the economy, and now you wonder why banks are interested. They want to be the first on this bandwagon to make as much money as possible out of it, and they for sure know about it. You saw UBS, but I know for sure that JP Morgan, Barclays, Goldman Sachs, they're all using this technology already. The cool thing is, it means that the world is in our hands as developers. Like, for the first time, the power is shifting now, if this thing actually works out, to us, to the people that write code, to determine which things get deployed, what's fair. If we're the only guys that can read these contracts, then we essentially are the gatekeepers to this whole new, potentially amazing world. So how do you make these apps?
So I have a question.
Sure.
And what are the limitations for amount of the people participating in this blockchain and the speed of transactions?
Okay, so right now there's
Could you repeat the question? I didn't.
yeah,
I'm
there's
sorry. The question is what are the limitations of this blockchain technology? On the first, on the amount of nodes of how many people participating in this technology, and the second limitation is on the speed of transaction in this blockchain, because it's no problem with Bitcoin, because the blockchain grows huge and there may be double blockchains and things like this.
Yeah. So basically, there's a bunch of different protocols emerging right now. There is no one true standard right now. Bitcoin's one, Litecoin's another. There's a bunch of different things. I'm going to tell you about one particular one that I'm interested in. There is a scalability concern with any technology, but as it goes down the line, as it becomes more apparent this thing's going to be important, you're going to get more and more smart people working on the scalability problem, and there are things like side chains and distributed blockchains themselves that can potentially solve that problem.
Chris, you said that all the power gets into the developers' hands, right? But we all know that developers never make bugs.
Yeah, I was thinking of a good question.
How is that going to be fixed if there is a problem in the code, right?
Well,
can you still stop it? Is it like a rampant thing?
I'd suggest implementing a testing framework to start off with. That might help. If bugs get into it, and there's no way around it, right? Once you deploy a buggy contract, it's going to exist, and it's up to you to let people know not to use this contract. You can't take it down. So
It's launch once and live forever.
exactly.
You have to relaunch a different version if you want to fix anything. Which you do.
Yeah, but there are systems that you, let's say you have a modular DAO, for example, and you can vote on which contract are used by that DAO. So if you have a buggy contract and you have a voting contract, you can vote to change which contract you use. So there are ways around it, but you just have to program in that logic. Writing, so how do you make these kind of apps? The answer is it's really hard. Like up until like 4 months ago, which is, I'll show you in a second, you basically had to be a crypto boffin in order to understand the whole stack and really implement everything from the bytecode up to the UI level, and actually deploying it and getting people on board is really hard, and you can't really build a developer community with that kind of barrier to entry. So a project came along called Ethereum. Ethereum is a new thing which has changed, in my opinion, the whole landscape of this technology for the better for you guys as JavaScript developers, because what it does is basically make it super easy to write contracts and deploy them. It's kind of like Meteor, if you like, where you don't have to worry about all the hard parts. It just exposes the business logic that you write and deploy. So what is it? According to Vitalik, who's the inventor, it's a decentralized mining network and software development platform rolled into one. So it's essentially like an IBE, an integrated blockchain environment. I just invented that. And it was invented by this guy. He was 19 when he created it. He's a Russian guy, and he's now 21. But he managed to raise $15 million on this idea.
1.5 or 5.0?
1.5.
1.5. That's good.
Pretty good. And he assembled this team in 2014, and they created the Ethereum project, which now exists. It's in production, people are using it, and it's huge. There's plenty of repositories. This is just page 1 of 5. And there are plenty of tools for all types of developers to get on board and start using this technology today. What they created is a Turing-complete virtual machine that exists on top of the blockchain. That means that you can write arbitrary code, compile it into bytecode, and run any logic you want without having to change the protocol in any way. It is a virtual machine that runs code on a blockchain. And this is the first example of this technology existing. And it's really cool because you don't need to worry about the underlying stuff anymore. You just deploy to that machine. It's a Dapps development platform. It's designed for developers and it makes the hard part easy. It takes away the underlying stuff and exposes the fun bits. But running contracts is not free, right? If everyone else is running these contracts for you, you can't just do it for free. So when you deploy, it costs a thing called gas. Gas is this concept in Ethereum that basically translates to real money. It's a price that fluctuates based on the network itself and can change, but basically it's a figure that translates into real money, and that real money is Ether. And Ether, just like Bitcoin, is a tradable token. You can trade it on Gatecoin if you're in Hong Kong, on any number of exchanges worldwide, for real cash and real money. Currently it's about $1 per Ether, but a transaction costs almost nothing. It's like a fraction of a cent. So in terms of like large costs, it's minimal. Smart contracts can own Ether. They can send Ether to other contracts. They can also run other contracts. So essentially, like I was talking about, you have these autonomous agencies that can potentially act in their own interest and can change owners, can deploy other contracts themselves, and own other contracts. The gas fees are based on the bytecode. So when you write a contract, it converts it into actual ones and zeros essentially, and for each operation there's a specific cost. So the bigger your contract is, the less efficient it is, the more expensive it is to run. So I see in the future there being a very good profession in optimizing smart contracts to work more efficiently by using less operations. And if you look at the price of Ether over the last few months, it's relatively stable compared to Bitcoin. There's a slight jump there, but it's comparable if you're a crypto trader to Bitcoin in terms of stability. A few projects in the world that exist. Ujo Music is one of the first things that they tried to do is essentially remove the need for record labels entirely. So when you buy a track, usually that money goes to the shop, then the shop sends it to the record label. But there's a lot of intermediaries, and it can take like up to 6 months for the end user, the recording artist, to get the money, and obviously they take a cut in between. So this smart contract allows people to deploy their own music and get paid for it, and directly get the money and share that between the owners of the intellectual property rights. And that's all done on the blockchain, doesn't cost anything, no intermediaries. Recording artists can now publish stuff, get paid directly by people, instead of having like 50% of their money taken by record labels. And that saving could be passed on to consumers as well. Another idea is Slockit. Basically their slogan is, if you can lock it, you can rent it. They've created this idea of a blockchain connected padlock, essentially, that you can attach to anything, a locker, a bike, a house, gym, whatever you want. And you set a price and you put a deposit on it. And if anyone wants to rent it out, they can do so for like a day, a micropayment. And during that period of time, they can open it and close it at will. And they only get their deposit back once they put it back where it is. So you're creating this trust mechanism on the blockchain that doesn't require either party to know each other or trust each other, because they're both putting a deposit into that contract, and only get their deposit back when they both agree with each other that this is what went down. There, sure.
So suppose I rent out my bike.
Mm-hmm.
When it gets returned, who assesses whether it was damaged or not?
The owner.
What if I'm not a trustworthy owner and I claim it was damaged when it really wasn't?
So it's only basically by both parties putting a deposit in, you only get your money back when the person agrees that you've sent it back in the right condition. And on the flip side, the renter only gets their money back when they return it in the right condition. So it's kind of locking both funds together until both people agree on an outcome. So if there is arbitration, in the future there will be more insurance contracts in the background running, but right now it's basically you lock each other into losing both of your money in a way that you'd rather resolve the issue than lock your money away. So it's kind of creating that mechanism. The other thing that Slockit have done is completely put their whole organization on the blockchain. So they're actually doing in real life a DAO. So anyone can invest in this company, anyone can get dividend, and basically make decisions on where they send services to, where they make their orders. If you have a company in India, you can propose to use this plant instead, and it might get voted up and agreed upon. It's a completely decentralized corporate structure.
So it's like a big Reddit thing?
Huh?
A little bit like Reddit?
It could be. I mean, you can write whatever logic you want into how you determine whether things can be done or not. It could be a simple vote. It could be a reputation system. It could be a bunch of things. It could just be one dude if you want.
In terms of the reputation system, going back to the lock example, the person before they enter the contract, could they find out the reputation of the person that they're going to go?
The idea is that generally everything should be
eBay or-
transparent. Like, you should generally know, hopefully, about everyone. And the reputation system is a good way of doing that because you don't even need to know them personally if everyone else has given them rep. And you can verify that on the blockchain. You don't need to trust that guy, you can trust everyone else that's given them rep.
Like eBay and
Something like that.
Airbnb, all that sort of stuff.
This is a website, if you want some more examples of Dapps. UI created by yours truly in React.
Oh, nice.
Yeah.
Nice.
My first React project, it's quite fun. But basically these are a bunch of Dapps that people have already created in Ethereum, and the color defines whether it's working prototype, work in progress, concept, live, etc. So you can view this website if you want to see some more examples. You might ask why I'm talking about this. I figured this would be about the right time to dive into some code. So, if you're a JavaScript developer, it's really important that Web3 is kind of pushed because it means that we get more work, more money. It's great for us because JavaScript is the language that Web3 is written in. If you look at the components of a Dapp, the user interface stays basically the same. It's just a web site, and with Electron, it's Node as well. So we don't have to learn anything new. All those backend developers have to change everything. Ruby doesn't exist on the blockchain. There's no SQL. They have to learn how to use smart contracts. But if you're a UI developer or even just a really good Electron developer that works with file systems and stuff, you don't need to learn anything really. It's just JavaScript. Possible structure for an Ethereum Dapp is you have some smart contracts. A lot of them are on GitHub, so you don't really need to write them yourselves, and a lot of them are reusable for lots of situations. You would have a blockchain interface, which I'll talk to you in a second. It consists of Geth and Web3.js, which is a library for talking to guests. Also a user interface, which you should all know about already because you write websites. Any JS framework you can use, Angular, doesn't matter. Meteor in particular is one that's adopted by the community. Some of the tools that Ethereum provides are listed here. So on the user interface side, you have a Meteor package system that includes a bunch of useful UI elements that you can use to automatically integrate with a thing called Mist. And Mist is like Chromium for Dapps. It's a Dapp browser. It literally has a URL bar. I'll show you later. Web3 is the JavaScript API, which allows you to communicate with Ethereum from your browser. Geth is basically the local client. It's basically like a server running locally that talks to other Ethereum nodes. And you have Solidity, which is the programming language, or one of them, that compiles into EVM bytecode, which you can deploy on the blockchain. So, Ethereum loves JavaScript, and it was built for us. So, Web3.js, now we can start getting into some code. You can require it like you normally do. So, yeah, let's Meteor JS library. How it works is basically you're running this Geth node locally, and it connects to your local instance on localhost 8545. And then there's a JSON RPC remote procedure called interface. So it's essentially a way of talking between those two applications, between the browser and the Ethereum node. You can tell it to do stuff like compile contracts, like run transactions, etc. And it also uses short polling to synchronize the data if you have a contract that has state. And it talks to each other. Okay, it gives you basically the full API of Ethereum. You can do anything that you can do in the native app through JavaScript RPC. You can make accounts, transactions, you can see your miner info and the block number, etc. You can compile code, so you can have a string of Solidity code, send it over RPC, and get back the compiled version of it, which you can then deploy from the browser as well. You get a dynamic contract API. So usually this Solidity code is not really usable in JavaScript, but what it does is create an API for you based on the methods in that contract. So you can interact normally like you would with myContract.payout. You can listen to events on the blockchain with event emitters. There's a secure messaging protocol, which I'm not going to talk about, and there's a few helpers like cryptographic stuff, conversion between different types. So, the basic overview of using this technology is start with a contract, compile the contract, parse the contract bytecode to generate an API, and then use that API in JavaScript. So, I'm going to do this in a live way, actually. So I have a little demo. So I'll open up Sublime. So this is just a very, very simple project. We have a HTML with Web3, which is the library, and Web3 test. Web3 is minified. This just basically sets up the connection, and I'm saving some source code. I'm going to do the rest in the console. So if I open this up, basically I've just in HTML put the code that I'm going to be using. Okay, cool. So first thing we notice, we're not connected to the node. So I'm going to fire up my Ethereum node right now. I'll blow this up for you. And I'm using a framework called Embark, which basically just means you have to type less to get the same thing. All of this code is generated, and it will automatically mine contracts for you. So it just means you have to do less low-level stuff. And now I'm connected. So I should see source. So yeah, so this source is just a string of Solidity code. It's literally just this. You can see here, it's just a function with multiply that will return whatever by 7. And what we're going to do is deploy this contract. Well, first we need to compile it. So let's take the source code, get a compiled object. In this object, we have the contract itself called test, and the bytecode is returned to us. We can actually see over here that the Solidity compiler got called over RPC and returned the compiled bytecode. This is not happening in the browser, it's happening in a get node. So it returns the bytecode, and you get some more info like an ABI definition. So an ABI is a way of understanding what the bytecode does, and you can then use that to create your JavaScript object. So let's just define a couple of variables to make it easier to point to what we want to point to. So we have ABI array, and we have the contract code. So this is just bytecode at the moment. And we're going to create like this is essentially like a shell contract. It's not deployed yet, but it contains the ABI. So it tells Ethereum that we know about what this contract can do, essentially. The next step is to deploy the contract. So we're going to take this myContract and just run myContract.new. And I'm going to console log a couple of things. Before I send this out, first it's going to console log every time we get the callback, and then it's going to console log mined when we get the address for that contract. So once I hit OK, we get the first response, which is, that's quick. We get the first response, which is the transaction for creating the contract, and then we get another callback when it's actually mined, and then we get the address of the contract itself. So now we have a deployed contract, and we can look at the transaction that happened. You can see here that the RPC protocol called this thing, and now it created a contract, and it mined the contract for us. And now we can actually play around with the contract. So let's look at contract instance. This is what we just got returned, and we have the method multiply now. So we can call that with 6, and we always get returned this thing called a big number, but it can be converted into a string. So we just deployed and created a smart contract. It works, we called it, and it returned the correct answer. That's a smart contract working on the blockchain.
Did you spend gas to do that?
I spent, yeah, so what I'm doing now is a test net. So it does use gas, but because I'm the only miner on the network, I can just mine every block and it costs me nothing. So I just get all the money. On the real network, it would cost to deploy, and yes, it would cost real money.
What would it have cost in that instance?
So a good question. There's a there's a way of determining how much it costs, but it's not much. Basically, I think at most like a cent.
Hong Kong dollars.
US. Guess. Cool. So that's just like the hello world.
It's a bit more of a complex hello world.
The hello universe is coming. So, next question, what about hosting? So we have this code, this JavaScript. We could put it on GitHub and have people pull it, but GitHub's centralized. So why don't we put it on IPFS? If you've not heard about IPFS, look it up. It's amazing. It's literally already changing, blowing up. It's crazy. You just need to learn about it. I'm not going to talk about it much, but this is like Web 3.0. And of course it loves Meteor. There are a bunch of Meteor packages that allow you to do accounts and stuff, integrate with the Mist browser, which I'll show you in a second, and style the app to look like the rest of the ecosystem. So to recap, things we talked about: blockchain, smart contract, DApp, Ethereum, WebJS, Web3.js. So let's build a distributed market DApp. Not Silk Road 3.0. Definitely not that. Basically, it consists of a registry contract and an escrow contract. The registry contract is responsible for listing everything that people want to sell, and the escrow contract, kind of like the Slock example where you're renting your bike, is responsible for taking deposits from both parties and ensuring the transaction goes through smoothly, and only returning the deposit when both parties agree that it has done. So the way that that contract works is kind of like this. So usually, if Alice wants to send Bob something on the internet, you would need an intermediary to take both items and then pass them on, because otherwise Bob would just leave and not pay Alice. And likewise, if Bob paid Alice, Alice could just leave, and there's no way around that. So you create a smart contract intermediary. Alice pays the smart contract exactly double the price of the thing she's trying to sell, and Bob puts in the same amount. Now, half of that is the actual value that he wants to send to her, but he also needs to put in a deposit to ensure that he doesn't screw her over when he receives the good. So what happens next is Alice sends it over. If Bob's happy with the product, he pings the contract and says everything's good. That's the happy path, and both people get their money back. He pings the contract, he gets his deposit back, she gets her deposit plus her payment back. So in that situation, you've created a trustless system for allowing people to send goods to each other. Let's replace this smart contract with a thing called Mist. Mist is the Dapps browser that I talked about, and hopefully this demo is going to work. So, what I'm going to do next is load up this, close this. First I need to kill Geth, which is the node that was running in the background, because for some reason it doesn't stop, so I'm going to kill that. And then open this up in Sublime. These are just some command lines that allow me to run everything I need for this particular DApp. Eventually, because it uses Electron, you can package all this up into a binary and just send an exe to someone. So you don't need to do all this stuff that I'm doing. This is just dev mode, if you like. So I'm going to create a new window, split it into 5, because I have 5 different processes running for this DApp, and paste all these in. So first, Geth. This is connection to Ethereum. Does everyone have a Mac charger? Next one is IPFS. It stands for Interplanetary File System. Basically, it's a combination of GitHub, BitTorrent, and mounting files onto your local machine. Pretty cool technology. Again, look into it, but I'm not going to talk about it. Next is the DApp itself. So this is a Meteor DApp. Basically, it's just a Meteor thing running on a specific port. And then next is the Mist DApp, which is again a Meteor app. And finally, once those things are running, I'm going to launch Electron. Just need to wait for Meteor to finish building. But you can see up here that when we first connected, it started syncing up with the blockchain, because every time you reconnect, you need to find exactly what the state is. So there's a few steps to go until you're ready. Now apps are running, I can run Electron. So Electron boots up. And now we have the Mist browser, and it is literally a browser. You can go to any URL, and then you can add it to your Dapps list, and then this becomes a locally existing Dapp. You can, without a server and running an Ethereum node, do cool stuff. So let's do that. I'm just going to check that my other instance is running. I'm running a separate setup, exactly what you saw on an Ubuntu VM. And what I'm going to do is create a new thing. So I'm going to sell myself this empty bottle of quality black. Let's put it in coffee. Junk. The price in Whey. Now Whey is like the smallest possible value in Ether world. So I'm just going to make it quite small. This translates to like fractions of cents, let alone anything legit. Just going to quickly find a picture of coffee. Just need a, yeah, that will do. Paste that in the image field.
Link.
Aha. Got it. And I'm going to choose this account to send it. So I'm going to submit this market. And Mist will basically jump in and ask me to approve this transaction. So I have a password on this account. Testing. Confirm that. And it's mining. So if we jump over back to Geth, we can see that we've created the transaction to send out that escrow contract. And it's going to do that. It takes a while, like anywhere between 12 seconds and a minute, because the block, in order to mine a block and confirm that the thing has gone in, it can be a difficult problem, it can be an easy problem, and it can range from a long time to a short time. Cool, so that transaction went in. There's another transaction now to update the registry. So again, put that in. And now it's deployed. So I have this thing on the blockchain, no servers involved, just distributed entirely. And if I jump over here, in a few seconds, it will take a while again because it needs to update, but we should see a new market for coffee appearing.
And destroyed something.
Over here, I think this is.
Socket is this socket 18 destroyed.
I think it does that fairly regularly. This is okay, transactions going. This is meant to take a long time. So
Q&A now?
yeah, Q&As are good.
How do you apply this technology to your day-to-day operation as a developer? Like, what do you feel like you should use this for? What do you feel you should like skip on?
For day-to-day stuff, I don't really see much application at this point. Like, the technology is relatively new, put it that way. And in terms of mass adoption, it's going to be a couple of years at least.
So you wouldn't consider the market at this point?
The people that are buying this right now are VCs and bankers.
So yes.
It's one of those things that kind of logically makes sense to start exploring that.
Exactly.
I'd
Yeah.
argue, right? At the very least, of course.
I mean, if what I've talked about is correct and the world is in our hands, surely it makes sense for us to be ahead of the curve, right? So that when it does reach maximum potential, we're already there.
Just for VCs and bankers' sake, is there a way to launch this without having like 5 terminals open?
Yes, that's by packaging it in Electron. Actually, the Mist browser that I opened here comes with a Geth node built in. So everything that you're seeing here would just be an executable.
Single execute.
Yeah. The only exception to that is Ipfs, which eventually will be installed on everyone's machine anyway.
But you can use GitHub at the end.
Yeah, you can use anything. That's just for distribution.
But there's a lot of trust in the developer too, right? Like, if doesn't like
isn't that where the trust belongs now? Is in the developer of whatever system's being made, or whatever developing company
As in, like, authoring the
of
contract.
this system, right?
So it's true, you can put whatever you want on the blockchain, and you can say whatever it is. You can say it's correct when it's not correct. But it's up to the outside world to determine whether what you say is correct or not.
Right.
What you can do is look at the source code, compile it and check that it's the same. You can look at the bytecode and make sure that it is actually what you think it is.
There's going to be huge, if this happens, there'll be a huge market for contractors that check. So you,
Potentially.
as a business owner, I'd have like 3 people that check that one person actually does it.
Basically.
So who actually runs that virtual machine now?
In the same way that nobody runs Bitcoin, nobody's running the machine. The answer is everyone is running it. Everyone that runs a node is checking that the transactions that happen are legit and fit within the logic set of that thing, of that protocol. And in the case of Ethereum, it's a well-defined protocol. And everyone that runs a node like I am now will confirm that the hash that's generated for that block is correct.
So if then the execution work is a lot of work, maybe there's a lot of code that needs to run,
Yes.
can it actually handle all that
So there is
load?
there's an upper limit to doing stuff, which is at the moment is 3 million gas. So you can do quite a bit, but you can also deploy multiple contracts so you can get away from that limit.
How is it all interconnected? How do you find the other nodes?
There's like
It's maybe basic
it's
for
a
you.
combination of like, I'm not really versed in P2P technology, but it's a combination of distributed hash table and peer discovery protocol. Not sure exactly how it works, but the cool thing about Ethereum is you don't need to understand how it works. You can just write the code.
Do you think there's a risk because, although maybe theoretically it works, do you think there's a risk because of the complexity? Because you made points earlier that like a day-to-day user doesn't need to know how HTTP works to take advantage of the web.
Yeah.
But that, it's just more browsing the web. And of course there's secure layers, SSL and so on. And that's widely accepted now that it kind of works. Most of it, enough of the time, percent of the time, right? And
Well, I mean, does
well,
it?
well, putting that aside, that question, good enough, right? At least. Do you think there's a risk to adoption of this because the level of complexity? I mean, I'm a developer, right? And this is blowing my mind a little bit. In a very fascinating way, really, genuinely.
I'm glad.
Uh,
I'm glad it is.
yeah, really, really. But I just wonder because what we're talking about is trust in a way that people. I'm sort of theorizing, putting it out there as a thought or question. Do you think there's a risk to adoption in a mainstream sense? Because it's like, okay, you need to trust this thing with more than just like with extra degrees of trust. And do you think that might hinder its more widespread like mainstream adoption?
I would challenge the assumption that there won't be extra layers of trust involved. I see a future where basically every transaction you make is insured by a smart contract, kind of like Visa, so you can do a chargeback. And those kind of institutions are it's way too early to develop them because no one's using it.
Yeah.
But I see an ecosystem evolving that deals with trust in a different way than just, depositing stuff into a contract.
Right.
I see meta things evolving and clever ways of getting around the problem of people not really understanding what they're doing.
Because it's not understanding, but then having faith and belief that it works, and true trust in a system that's inherently very, very complex. And, using like cryptography and all these things that average person is way over there, right? But
I mean, you can put the same argument against SSL, right?
yeah, or even Visa. I mean, Visa is kind of to most people like an abstract entity. There's a lot of banks and intermediaries right now that we implicitly trust. I'm not saying I don't think it's very interesting, so I'm just putting it out there as a thing, because even someone who programs day to day does consider myself reasonably technical. This is still like, my goodness.
It's honestly, I mean, 4 months ago I had no idea this stuff existed, and since then I've just deep dove, and it's crazy how amazing this stuff is. Especially in Hong Kong, man. This place is the place it needs to be. There's in terms of regulation, if you look at the States, they're already doing Bitcoin licenses. So you're going to need a license to even deploy this kind of stuff. But in Hong Kong, this is where it needs to happen, I think. So we have the right mix of finance and developers, and it's actually not just JavaScript, but also low-level stuff, computer science.
We need to wrap up. I think we're getting kicked out in a
Okay.
few minutes.
How do you plan
maybe
on
2
using
more
it?
minutes if that's all right. We'll wrap up now. Last couple of questions.
One more?
How do you plan on using it?
Sorry?
How do you plan on using it?
There's a few ideas that could be done. One, for example, if this market concept, not this one, this is just a demo, if it takes off, ensuring transactions is a big one. If you can create a way of having like a crowd-funded insurance model where everyone gets a percentage of most of things that don't go wrong, and basically the only time that you have to pay out is when people die, then I think that's a very easy to implement and right now is useful thing. In the future, I see stuff like auctions for ad space networks, right? If you have a TV in Hong Kong and you want to like rent out that space, you could put a contract on the blockchain where anyone in the world can basically rent out that screen for an hour, and you put the advert on there.
On an individual screen basis.
Yeah.
But then of course it could be done at
Exactly.
scale as well. Yeah.
Does this present a threat? Does this technology present a threat to totalitarian regimes that like to censor
Yes.
censor the internet and stuff like that?
The internet in general does.
By all means.
Well, there's two ways of looking at it, right? Sorry that demo didn't work, but I can show you later if you're really interested. I think that if you look at the world as it exists, it's effectively going to be the same functionally, like the outcome will be the same, but it's just going to be way more efficient. So you're still going to have the same forces at work, but you just cut out the middleman that prevents those things from acting out as efficiently as they can.
Just to extend on that, only from having read that Economist article, less corrupt as well, because they cite an example of one of the Central American countries wherein I think like land ownership or property ownership contracts, stored in probably a paper-based filing cabinet somewhere, and inherently very very corrupt, and officials get bribed to forge contracts or tear up a contract, and then someone will basically claim ownership of land or whatever. This is just the example they give, and I think they're actually exploring using the technology, right? Pretty progressive. To have it built into the blockchain of who owns what from a land distribution perspective.
One super cool application on the topic of like being more efficient by being less corrupt, I think that's the takeaway there, is like welfare state, right? If you can donate to a contract that automatically distributes all the tax to the individuals as opposed to going through all those loopholes and various mechanisms of government that are potentially making it less efficient, then probably better to do it with smart contracts, and it's free. Vlad.
I have like 3 questions.
Last questions then. Or like,
First one, I agree a little bit with Kevin in terms of it is probably a little bit early for developers per se, right, to look into it.
Okay.
But at the same time, right, there is definitely a way to leverage it like these days. Maybe IPFS is like part of the solution, right? Which is like take advantage of this, not everything out there, not the transaction mechanism, but overall like distributed everything is like the next step to go, right? Especially with outages with GitHub and NPM and other things.
Yeah. So the point about it being too early, if you look at the momentum for like just general buzz around a project, I've never seen this level of like interest for any particular individual project ever. Like it literally came public 6 months ago, and since then it's just snowballed essentially, and you have a massive increase in the amount of adoption of this technology. I think this time next year, you most certainly will be using smart contracts, whether directly or not, in some institution somewhere around your bank account. They're already using it in Wall Street for clearing stock exchange.
NASDAQ is trialing it as well.
That NASDAQ have their own private blockchain that they use for clearing.
definitely snowballed into this room right now.
Well, I
This is spreading the word.
Yeah, so I went to DEFCON in London. That was a couple of weeks ago, so just bringing back the information, spreading some memes to Hong Kong.
Okay, on that note, I think on that gesture.
So,
We need to
knowing
wrap
that,
up.
knowing that Hong Kong is the perfect environment, right, for this kind of technology to be adopted, do you consider yourself being in Hong Kong in the near future to sort of adopt this shit?
So I'm like 90% gonna work for the core Ethereum team in London.
Probably not.
No, 90%.
90% sure, yeah. So I won't be in Hong Kong potentially much longer. So this might be my last talk.
To the webcast.
Nice.